Yeah.
Okay, so we're broadcasting here, another little Google Hangout on air. I've been loving Google Hangouts. And what's so great is I haven't talked to Edward Ford here in a while. And of course, as everybody knows, he's the inventor of the Shapeoko, which has created this whole community. I sometimes lovingly refer to Edward as the Linus Torvalds of the CNC community. I hope it makes you blush, Edward.
It does. It does. That's a good designation. I will take that all day.
Okay, I'll keep repeating it until other people do.
I would appreciate that. I would do it myself, but it's a little horn tooting, and
You can't.
yeah, that's not really my style.
No, you can't do that. But so good.
Yeah.
So thanks for hanging out with me here for a little bit to talk about the state of the CNC community. Um, I think there's some really fun stuff going on in the software side of the business. Obviously, you're heavy on the hardware side, but it's kind of that marriage of the two that I think makes it magical. So,
Yeah,
you know,
one of them doesn't really matter without the other. So from my point of view, the hardware stuff is, really sexy. The software stuff is, because I don't do it, a little bit of black magic. And it's been really exciting the last couple of months, man. There's been so many things that have popped up. I feel like we're finally getting, software CNC-wise is catching up with the hardware. So yeah, we're moving along. It's been great.
yeah, and I love software, but I've caught this sort of hardware bug because it's so exciting, the idea of software controlling hardware and kind of bringing those two together. I think it is tough because there's all these different people kind of doing different things, and I think for most of it, like for me, this is just sort of weekend project stuff, so it's hard to get too much time to spend on it, but it sure is exciting.
Yeah, absolutely. Some of the stuff that we've seen come out has been phenomenal. Like I'm thinking of Jscut right now. I know that you did a hangout a couple days ago about it. We'll probably talk about that a bit more. But to think that Todd put that together in just a couple of weeks, it's amazing.
Yeah, I totally agree, and I think that for the software space, the browser has come such a long way. With things like WebGL, it's creating this basis where I feel like the browser is a better environment to write software than to go write it as a native desktop app in Qt or write it in Java or JavaFX. And then, of course, you get the cross-platform capability. So I think it's changing the game.
Yeah, absolutely. To think, I don't know, even 5, 6, 7 years ago, if somebody would have said, "Hey, your CNC machine, you're actually run that from the browser," I probably would have smacked him in the face and called him a liar. It seems like that would have been impossible to do, and now we're running everything from the browser. I mean, can run my coffee machine from the browser.
Exactly. I mean, we moved to the browser for our email. We moved to the browser for our online meetings. It's just the browser is almost a better operating system than the operating system itself, like Windows or Mac.
Yeah, absolutely.
So what I'm dying to know, Edward, is what have you been up to? I know you've got your day job, and I'm sure your head's down on that, but I'm excited about anything going on in the Edward Ford brain there in terms of the CNC world.
It's been really interesting since leaving Inventables almost a year ago, sort of taking a step back from the project and, from 20,000 feet, really seeing it, how people are interacting with it and who's coming on. I spent about last year just like watching. I had some ideas for something new, but I haven't really. I've done a lot of tinkering, but nothing serious right now. I'm really anxious to roll up some sort of software package to go with the machine. So I've been keeping my eyes on that. I've been talking to Todd for a while about Jscut and the other options that are out there. But I don't have anything huge on the back burner.
Well, let me ask you, because of course I've got a couple Shapeokos, and there's some of the things that I would love to see are, the timing belt is great and it's cheap, but I kind of want to go a little bit more precision, try and get rid of any tiny backlash, because I'm trying to do control stuff down to like the micron level, and so those are some of the things I'd love to see. I mean, of course you can whip up your own thing, but it's always nice to have the Edward design.
Yeah, we have a couple of, there's a couple of users on the forum. I've got a Shapeoko kicking around somewhere that's leads through driven. It was actually a pretty easy hack. But sticking with like the core of Shapeoko, not having to fabricate anything, I really don't want to release any sort of, hey, here's a screw-driven option without really having it, buttoned down where, hey, you either cut these parts yourself out of aluminum, or we got a couple pieces of laser cut steel that you can buy and sort of bolt together. So it's coming along. Screw-driven machine versus belt. There's so many pros and cons to both of them depending on what you're doing.
Yeah.
It really is just 50-50.
So you don't necessarily think there's any huge advantages to it. In fact, maybe there's more disadvantages. You probably considered it in the original design and said, no, I'm going the timing belt.
So the one thing that I love about Shapeoko still today that I loved from day one is the fact that you can expand it pretty easily, from this sort of stock 500 by 500 millimeter to all the way up to a meter and a half. If it's screw driven, it's a lot more expensive for one, but you run into some sort of mechanical problems with screw whip and things like that. The path to scaling it gets much more difficult with screws. So the timing belts are great, man. Just pitch your old ones, buy some new ones. They're like $1 a foot or something.
Okay.
Double your size.
What about the idea of no timing belt, but the maker slide has notches etched in it, and there's a cogwheel on the stepper motor just sort of going along the cogs?
Like a racket pinion, or are you talking about some sort of feedback loop?
I don't know. Let's say somebody figured out how to etch in this perfect little, these little triangular slots in the maker slide, and the gear on the stepper motor is just sort of right on it. I mean, it's sort of aluminum against aluminum, maybe. But
yeah, there were actually a couple of people, we were calling it the poor man's rack and pinion, that basically super glued the timing belt to the top of the maker slide rail.
Oh, interesting.
And then they adjusted their motor mount plate so the pulley literally sat on the timing belt, and it was just like a rack and pinion, except it was a neoprene belt, with a stepper motor and a pulley on it. And surprisingly, the first guy who did it, he was cutting aluminum with it.
Yeah, there you go. Well, because I still struggle a little bit with the rigidity of it. When I'm doing a lot of PCB milling, so the detail work is pretty intense, and so that give when you start to kind of go down into the FR4 can mess some stuff up, especially on curves.
Yeah, absolutely.
And so you, of course, went way more metal on the Shapeoko too, like almost metal everywhere, no plastic anywhere.
Yeah, but I don't think there is. Well, you
got the Delrin wheels still, so.
Yeah, Delrin wheels. Otherwise, it's all metal, aluminum, or steel.
Right, which is pretty sweet. And then go ahead.
We doubled up the X on Shapeoko too, which I think added to the rigidity. Without the maker slide being wider, it's we're at the max right now for how rigid we can make it. But you've seen examples, and you've done enough PCBs to know that if you get your settings right, you can get pretty tight with it.
You can. And in fact, what I found the best way to handle it is you just don't dig too deep into your PCB board. You just do multiple passes, so that that's less of an issue, that rigidity.
Yeah, absolutely.
But then, you better have perfect repetition. And I will say, even though I feel like I've tweaked the settings like crazy, I still feel like I lose stepper steps. Even though everybody in the CNC community says you should never lose steps, I still think after I've run a 3-hour-long job, one of them or two of them got missed, and then when you're going back for another round, everything's screwed up.
Yeah, it's amazing. If you're doing a PCB where the pitch is really fine, losing a step or two counts for a lot. I remember about a year and a half ago, Wilhelm, one of the members on the forum, and he's actually one of the moderators on the Google Plus page, the community page, made this really sweet, it was almost like an IDE that had an integrated webcam with the crosshairs, and you could pause and basically re-zero your job midway through and run it. And it was basically just for that. It was for any sort of missteps or miscalculations.
Yeah, but then when I hear that, I think, isn't he really getting back to an exact spot at the micron level?
Yeah, the only thing I can say to that is the before and after pictures were pretty amazing. His thing was basically, milling out pads that then you would drill a hole through to like mount a chip on, we'll say. So he would route all the traces and then basically come back with the camera and do his crosshairs in the middle of the pad, and then that would start his job over. And the before and after pictures were pretty phenomenal.
So here's what's interesting. I now want to go play with this software you're talking about, but I feel like it's probably somewhere lost in GitHub. It's
Yeah.
maybe it's Java, trying to go get it to compile, back to this painful situation in the software world, which is partly what I think could be solved by the ChiliPeppr model, which maybe we'll get into a little bit later. But why is there no pick and place open source software? There's this sort of open PNP out there, but I couldn't even get the thing to run, and it hasn't been worked on for a couple of years. Where are we with this? The whole community needs to get all of these pieces in place. We should be able to assemble an entire circuit board from milling from scratch to pick and place to squirting solder paste onto it to throwing it into our toaster oven, and we're done.
Yeah, it's pretty. On the one hand, it's pretty amazing how far we've come in the last, let's just say, 5 years, with a lot of people sort of scratching their own itch, making a solution to their specific problem. If you look hard enough, you could usually find, okay, somebody's already encountered this, they wrote this to sort of solve the problem. Your chances of reproducing the setup are pretty slim. But yeah, if we could sort of focus that effort, make some sort of giant community checklist of, hey, these are the topics, top down. If you're going to work on something, work on one of these and feed it back into the community. That would be phenomenal.
Yeah, exactly. I mean, it's how we got Linux.
Yeah.
Mr. Linus Torvalds. Okay, so now why isn't more of the 3D printing community using Shapeokos as their framework?
I don't know, actually. This is sort of embarrassing. I've never used it as my 3D printer framework. I had one set up once, ran it through the motions, put it back to a mill. I don't know, to be honest. I know that there are quite a few people that do it, but I'm not sure why more people don't.
What's interesting is a couple of things. I think one is I bought a bunch of parts, I don't know, 6 months ago, which, probably over the Christmas break, and I never actually finished setting it up either. So I'm kind of in the same boat as you. The other thing I think is it just too big of a rig for the tons of micro movements and layering that the 3D printing world needs? You're moving too much metal for each move.
Yeah, so I sort of laugh to myself a lot when I see, and you've seen quite a few of these pop up over the last, let's say, year or 2 years, where people are making this sort of all-in-one deal. It's a mill, it's a 3D printer, it's a laser cutter with
I reject that too. That's like trying to make the unified inbox. It doesn't work.
Yeah, they're optimized for different things, right? Like with milling, you need sort of mass and rigidity. And for 3D printing and laser cutting, for that matter, you need quick, lightweight movements. You pick one. You can't have both. Choose one.
So what's your take on the other mill? Have you checked out the other mill?
Yeah, I've seen the other mill. I don't know enough about it to really speak, directly of it. It's a neat looking little machine.
I agree. I think it's pretty sweet. I saw it when it first came out on Kickstarter. I thought it was pretty awesome. I thought the price point was pretty high because I think you can achieve it on Shapeoko, but I do think you got to do a lot of your own stuff on Shapeoko to kind of pull off what they put in a really nice complete package, including their software.
Did you back the project? Did you back it?
No, because it was I don't know what, $1,000 or $1,200 or something. So
I think it's more. I think it's $2,500.
Oh, whoa, that's even more.
Yeah.
And I still look at the Shapeoko. If you can pick it up, the base kit for the couple $100, and I think I got the early one for even cheaper. and then you throw a cheap controller, you're pretty much good to go. Although you got to go get a good, a good motor for the end mill. So it actually does sort of add up. But then I still feel like you've got a more flexible platform.
Yeah. The only thing that I really know about Other Mill is the area. It looks like they're focused on PCBs. The area that you can mill, it's like maybe 4x4 by inch and a half or 2 or something. And the few projects that I've seen out of it, look pretty neat. I think their software is Mac only, which really surprised me.
That kills me. And with doing this whole ChiliPeppr thing, which just started out as this little weekend project, whipping up some widgets, and then it kind of started coming together nicer. I was like, because I am not a Mac guy. I am a Windows guy, which of course some people make fun of me for. But it does kill me that it's just Mac only, because I think it's too bad. I almost wish they had done a browser platform, or maybe I had ChiliPeppr was further along and they would have said, "Hey, John, what if we just sort of extend and make we fork a version that's more specific to Other Mill."
So tell me that this is a pretty good opportunity. I'm going to tell you what I know about ChiliPeppr,
okay.
and then you're going to tell me the truth, okay? Because I read all your stuff, I watched the videos, and from again, like 20,000 feet, it looks like, okay, it's a way to control your mill from the browser. But I have a feeling that it's more like, it's a lot more than that. Like, you can go super deep into it. It's more of a platform than anything. But at this point in time, like, I'm having a really hard time wrapping my head around why should I jump on this bandwagon, other than, you made it.
Okay, so, how have you done a lot of PCB milling?
By a lot, you mean some?
Yeah, sure.
Yeah, maybe a couple.
So,
but I'm not much of a circuit designer. So most of the time, to be honest, I send my stuff off to OSH Park, and in a couple of weeks, I get a purple board back.
No, I agree. And actually, I love OSH Park. And so, milling PCB, sometimes it's like, why am I doing this when I can just ship it off to OSH Park? But it isn't just about milling PCBs. But when I started looking for a lot of the tools out there, and of course I'm a fan of the Tiny G, and I would use TGFX, but it was so hard to just keep it going. I always had to run it out of the NetBeans IDE, and if I wanted to do anything special or custom, like even make the motors freeze so I could do an end mill change without the X and Y axis moving, it was just it was painful, but there's no 3D visualizer, things like that. But so it did its thing. So then you go and you try and use a more popular package like what you recommend, like Universal G-Code Sender. But doing that for Tiny G still, I don't think, is in the package. So I actually remember forking it on GitHub and modifying it, but it was always a really barely workable implementation. So I always felt like I just still, after maybe even a year of playing around on little weekend projects, I still never had good software to drive my Tiny G Shapeoko. And I was like, there's just nothing happening in the community to go do it. And then if you want to do anything, like I was desperate to try and auto level my PCB, because you go and look at videos about Mach 3 and the auto leveler, and you're like, oh man, I got to go move to a platform like that. And I feel like the software's not that bad to go auto level. And so I just sort of started playing with direct control of the Tiny G for the Shapeoko, and started just kind of whipping up little JavaScript widgets in JS Fiddle. And one thing led to the next, and before you knew it, I had this entire full-blown package that I was using on my own, and I'm like, I should probably just let other people do it. But to have each little element written in JS Fiddle created this whole ability to just go look at the little individual widgets, like the 3D Viewer widget on its own, or the I should almost do a little screen share on this, because in fact I will. I'm going to pull up the screen share on it, because for me it turned into an operating system. So let me swap over and just kind of show you. So I've got it running right here. And are you seeing that?
Yeah.
So, this auto level is this new feature that I just threw up there over the weekend, and I'm loving it. You know, this 3D viewer's got all this awesome stuff. I still have never been that thrilled with any 3D viewer in any of the packages out there.
Mm-hmm.
I never was able to really just see what was going on right to the serial port, which always bothered me, because even if you're throwing a little jog command, you know, if I go and jog this 1 millimeter, I kind of want to see, like, what command did the software just throw out there. So if I'm going to go do my own scripting, can I just steal that?
Right.
And sure, if you've been doing a lot of CNC, you're like, duh, Lauer, it's G91, G1, blah, blah, blah. But, you know, when you first get into it, you have no idea what all these commands are.
Yeah.
Which is why, even out of desperation, when I was working on this little widget, I'm like, wait, what's G21 again? Oh, that's millimeters. You know, and so that's even was sort of the necessities of the mother invention to get some of those in. And it's like, if I'm going through that same thought process, so are other folks. And then
it's super interesting, just to completely cut you off real quick. You know, listening to you describe this, in my mind, I have a lot of CNC users segmented into these different groups, and you know, you're clearly in the, and this is a pretty large group for Shapeoko users. You're clearly in the, like, software developer group, right? So you want to apply your skill set from, you know, what's now software into software plus hardware. And I can see so many people just absolutely geeking out about this. Like, it looks phenomenal. Just carry on now.
Well, thank you. I appreciate that. It means a lot coming from you. And I feel like it looks pretty sweet too, but I'm biased because it's been, you know, it's funny because I would say the majority of this got written between Christmas and New Year's. That was a long time ago. And I only just sort of put it up on the web maybe 3 weeks ago for people to sort of start playing with. But, you know, this WebRTC client, right? In my day job, we do all this text messaging software, and we've been talking about adding video chat. So I deal with this stuff every day, and I'm like, WebRTC is so awesome. But I want to see my Shapeoko while I'm working on it, because I'm rarely in the same room as it. I might be when I set it up, but then I'm upstairs, I'm on the back patio, I'm running around. So just the fact that I've got a live video feed now of this thing, I love it.
Yeah, that's pretty awesome. Can you stream more than one camera?
You absolutely can. So one of my little secret projects, which I almost don't want to share on this Hangout, is I've got a Shapeoko in the works that's got about 16 webcams on it.
Whoa.
And in the 3D viewer, the goal, we'll see if I can pull it off, is that you're actually almost turning it around and seeing the live video stream.
Oh, I see what you did there. That's pretty clever. So, I would like to see that.
Edward, this is why ChiliPeppr makes so much sense as a base operating system to then go upstream with things like that, because why don't we have that?
Good question.
We don't have it because you'd have to write something from scratch if you wanted to go work on that project.
Yeah, absolutely.
And
so do you say, just quickly, I just thought of this, do you say whipped up widgets because of the alliteration, or is that what everybody says when they make a widget? They whipped it up.
No, that's probably just my lingo.
Love it.
Lame-ass lingo. So take, for instance, this little Jscut widget, okay? So one of the tricks in this is each one of these little triangle menus shows you how to fork the widget or look at the pub sub for it. And it's pretty nerdy, but Jscut is what I worked on with Todd Fleming on Sunday morning to integrate. And I just click fork, and there it is, right? The Jscut widget's running all on its own in its own little window. And here's the code for it. There's not a lot to it. And all of a sudden, we've got this great integration with your toolpath flow.
Yeah.
So you get your HTML. This JSFiddle is kind of acting like a GitHub, but the difference is, if I want to go and turn the footer on and add some status thing to it, you hit Control-Enter on the keyboard, and now I got a little footer, and I can kind of play with it, and then you update it and publish, and it's done. Or that's logged in for me, but if you want to fork it and make a different version, go for it. That's never been possible on GitHub. Yes, GitHub's great, But to go check out somebody's project and completely like change the whole thing, it's almost like what this model is it's as if there's a GitHub project for each one of these widgets, and you're able to just fork it on its own and still use the majority of the widgets. So it is a different model. It's so different than anything I've ever seen out there. It's probably really foreign to people. But hopefully maybe that changes, because this is a TinyG specific workspace, but if somebody were to just come and fork the TinyG widget and call it the Gerbil widget, and just tweak some of, like when you go and ask for what the status is of the TinyG, you got to go send in this little SR command. If it's Gerbil, you send in the $ command. That's all you got to do. Tweak it. But Gerbil doesn't have this thing called a planner buffer. So how do you do flow control for the Gerbil? It's a little different. I think you do it based on sending commands in and waiting for like a new line response back. So you just count new line responses. I think TinyG does a way slicker system, but to each their own.
Yeah, interesting. So right now, TinyG is the only supported thing you got going with this.
It's the thing I've been working on. So again, this was sort of just, for me, it was the necessities, the mother of invention. I may myself go do the Gerbil version because I've gotten so much feedback on people desiring it. And I do think, I don't know the stats out there, but I'm guessing Gerbil's maybe 3 times more popular because it's cheaper. What's your gut? 10 times more popular?
Yeah, at least.
Okay. But
you should actually you should do one of these hangouts with Sonny, the guy who's running the Gerbil project right now.
I would love to. In fact, what would be great is for us to collaborate on a hangout and just fork the TinyG right there live.
You guys could pair program on it. It would be pretty phenomenal.
Well, so really what you do is you come over here. Let's rename it to be the widget Gerbil. Change the description. Here, we'll do some extreme programming. We'll call this right here Gerbil. We'll fork it. Okay, here's our new Gerbil widget. Obviously, there's no planner buffer, but just go with me on it.
Yep.
We'll come over to the workspace. We'll fork that. We'll call the workspace Gerbil. Is it Garble or Gerbil?
I don't know. I used to call it Gerbil. But it's not Gerbil.
I might have done that too early on, but so this is the part where you then got to kind of figure out where the heck all the HTML is. I don't want to get too lost, in the weeds here, but the point here, workspace Gerbil. All right, I'll fork that.
What's the are you using Bootstrap for the HTML?
All Bootstrap. I'm completely cheating and just going all Bootstrap. This is why it looks like most of these modern day apps.
It actually doesn't look like anything I've ever seen before. I was completely sort of in a trance when I saw the first link that you sent me.
Yeah, I love it. I love that kind of feedback.
What is this? What is John doing?
Okay, so here, Gerbil, and then here's the magic part, right? See this fork boot script? So on Linux how you basically got these boot run levels, and only when you're run level 5 or 6 are you actually in the OS. So I'm going to fork the boot script. We'll call it Gerbil. And then, see this right here? That little code, or whatever your JS fiddle's got to get tweaked. So we'll throw this one in. There's that. Save our change. Successfully saved. ChiliPeppr.com Gerbil. And we're done. Well, the only thing we got to change is the TinyG's got to get swapped out. So notice we're in the workspace Gerbil. And then we just got to make sure that this guy is being swapped with the TinyG being loaded in here. So we'll just go down to where it loads the TinyG widget. So what it is it's a JS fiddle loading sub-JS fiddles, loading sub-JS fiddles.
Man, that's a rabbit hole.
It's awesome, but it could be a little intimidating. So see this little tiny G right here? Let's
Yeah.
swap it. We're gonna swap that out, and we are done. It should load over here. It's kind of funny seeing a full ChiliPeppr in this tiny little window. There it is, right there. And we'll set his base, which is basically like moving it to the master branch. We'll come back here, reload, and we got ourselves a gerbil or a gerbil ChiliPeppr interface. I wanted to show that to you because this is an operating system that can get extended to let people do whatever the heck they want to build on all of the tools that are already here.
Pretty impressive.
Because, you know, this serial port widget, I got to say, this was a ton of work to get this set up initially. This serial port, none of this would work without that thing.
How does it communicate from like just a layman term? You know, I think from the OS side, you would have a driver, and then that would, you know, get you set up talking to your Arduino through the Arduino IDE. How do you give the browser permission to talk to your hardware?
Okay, so this actually initially was the big trick to say, is this doable? And, you know, I'll disconnect, and it's this whole serial port JSON server. So that was a decent amount of work. I think I did write most of that over the Christmas break too, because I was kind of getting into Golang, and I wanted this thing to be really lightweight and be able to run on the Raspberry Pi. And then when Beagle Bone Black came out, I was like, this is even sweeter. So this little serial port JSON server speaks to the serial port, which is, of course, is always this native thing. And I think it's why you find so much desktop software out there. Because if you're going to talk to the serial port, good luck doing that in the browser. It's like impossible. Right. Good luck.
Well, the whole idea, right, is to separate the browser from the PC to give you some sort of isolation, security, yada, yada.
Yep.
So now you're basically trying to go around that.
You're definitely trying to pierce the veil of the browser sandbox to get access to that darn serial port. And not only one serial port, but multiple serial ports. And that, I think, is magical here, too, is you can be bound into multiple serial ports from one UI, and I think that could lead to some other stuff. So, like, this initial probing that I am doing for this auto leveling, I initially rigged it up to an Arduino so I could just read, you know, values off of that when the circuit was connected. I just was talking to two serial ports in parallel, one to the Tiny G and one to the Arduino. Why should that be hard?
Yeah, interesting.
But good luck doing that with any existing G-code sender app. It's not going to happen. And then to try and sync the two, just like send G-code commands based on Arduino feedback, there's just no way you're going to get there. This is totally doable now. So that this source code over on GitHub is all Golang, and it's just sort of its own little standalone project, but it's got the WebSocket, which is sort of this whole little hub, you know, code here. It pulls out the serial lists, which are specific to each platform, so that's some work. In fact, even reading, let me reconnect. Even reading the nice name on Windows, you don't get that in like any product. Even in the Arduino IDE, it doesn't show you the name out of the registry. It just shows you COM22 and 23. And I always struggle because I'd always have like 10 serial devices plugged in. I'd be like, I don't know which one.
Which one is it?
So yeah, that was the magic. And then, you know, doing WebSockets though in Go, super easy. Like there's libraries written. It's, you know, even Google App Engine has a WebSocket, and so that's the library. I mean, it's come a long way. But this thing running full, I don't know if you've looked at it when it's running. It uses up like 4 megs of RAM and barely goes beyond 3% of your CPU. Wow. I mean, it is sweet.
Yeah.
It is so sweet. And then there's concern out there, I've heard, like, okay, but when you start sending G-code, do you start overwhelming the WebSocket? Is the WebSocket brittle? And I really don't think that that's going to be the case. I mean, a WebSocket is just a TCP/IP connection. What's the big deal? Streaming one YouTube video is more taxing on the internet and your computer than throwing some G-code out. So even this Octocat.
Yeah.
It's been an hour, Daddy.
I heard that. I heard that.
Where's my Octocat? I want to bring that in there. I don't know if I actually have it. That's a pretty intense. Oh, whatever. I don't want to get too. Oh, here it is. The famous Octocat. I mean, that thing renders like a beast. That's a lot of G code, and it's 25. It's only 25,000 lines. I guess it's not that bad, but I think that could fly.
So, did you tweak the? Well, talk to me about the Webgl Viewer here. Did you start from scratch, or did you borrow from some of the existing?
Okay, so Joe Walnes had one.
Joe's actually a Chicago guy. Just to give Chicago a plug real quick. Joe's a Chicago guy, and that was the first one that I thought of because he was the first guy that I saw do it.
In fact, I think when I saw that, I don't remember how I stumbled onto it. I was like, "Oh my God, that is so sweet!" Because I was always like, is Webgl really ready for mainstream, or is it just like a toy? And when I saw that, I was like, "That is so great!" Because trying to do 3D even in Java is still really pretty brutal. Or trying to do it in like C++, even worse. So that made me think it's pretty doable, and then it could handle some of this intensity. And so I definitely did check that out, and I give him some credit inside the, if you fork the 3D viewer, I put some credit in there for him. But boy, did I go deep on this, like big time. So, the ARC commands, these are brutal. And
I was going to ask if you made accommodations. I see there's a bit of a color scheme going on. I didn't know if you're representing straight lines and arcs with different colors or...
Yeah. So here's the thing. The light line, which is supposed to be really light, is to kind of represent the start and end point. I probably shouldn't show it because it can be confusing, but then this is the arc, and I do have to do sub-rendering. So I'm definitely rendering arcs correctly, but I'm doing them light blue just to kind of indicate that they're arc commands. Most people probably could ignore it, but even getting arc commands on using the R parameter, I got it to work the right way, and there's not a lot of even other software out there that does that. So I tried to be pretty comprehensive.
It looks pretty amazing, and I know I've said that a couple of times, but it really looks nice, John.
Well, thank you. And of course, the shout out to the Shapeoko here. Because what I feel like I don't really have in great shape is the support for inches, which I notice you tend to use.
Actually, the funny thing is that in my everyday life, I never use inches at all. Everything I draw is in millimeters. The whole machine,
was
both
in millimeters.
All upgrades have been in millimeters, but the Hello World that I did was in inches, and I still don't know why it was in inches.
It was the way you did it, yeah. So
it's so funny, all the decisions you make, like sort of getting these things out to market, if you will. People come back and ask you these questions all the time, like, dude, why is this in inches? Yeah. I don't know. Yeah, I have no idea. I click save.
Yeah, totally. Now, what I would say is, if you do a different plane than XY, those arcs will fall apart. So either somebody in the community, please go fix that part of the 3D viewer, or don't ever switch out of the XY plane. So I know you wanted to talk about Jscut a little bit as well.
Yeah, just talk to me about you interviewed Todd a couple of days ago about Jscut. I'll just say again that I think it's amazing that Todd and his brother, I think, whipped that thing up in a couple of weekends.
Yeah.
And it's something that the open source, both software and open hardware CNC has really been desperately needing some sort of jumping off point. I've been hosting MakerCam or whatever for the last, let's say, year and a half,
That's right, because the guy who made it took it down, and then you asked him for the code base, and
yeah, so he actually put the code base up on somewhere not called GitHub. I don't even know the name of it. I found
Bitbucket
it.
or something, or
Yeah, something like that. I found it. I emailed him sort of relentlessly, gave him the rundown. He was super. Jack is the guy's name. He was super appreciative that somebody else was appreciative about MakerCam because he had made it, sort of released it to the CNC Zone community, and they basically said, meh, we're not interested in a CAM program in the browser. And I think he was just ahead of his time.
Yeah.
But as far as extending MakerCam, it was a non-starter because it's written in Flash. So I feel like Todd, to get back to JScut, I feel like Todd really gave us something to start with. And where he started, like what he's done, him and his brother, it's absolutely phenomenal. Having seen other people try to do this,
it really is.
It's really hard, and he made it seem easy.
Did you watch the video I did with him?
Yeah.
Because he explained to me how, and I've doing that 3D viewer. It was a lot of work. That was probably one of the bigger pieces of the project. The way he's doing this 3D rendering is so awesome. I've never seen anybody do it the way he did it. I mean, he's right down to the writing shader algorithms. They're loaded by the browser, but it's actually more like C code.
Yeah,
the browser's passing in as shaders.
Yeah, if you grab the project from GitHub, you see those shader files, and I was like, what on earth? What is this?
I looked at them, and I was thinking about doing some shaders, but that is super advanced. And he said he's generating 1 million triangles every time I do the slider.
Yeah.
And it's just barely taxing my system. I mean, it's the Google Hangout that's chewing up my CPU here.
Yeah.
So it is just really, really well done. And I feel like we're lucky in the maker community to have a guy like Todd put this together. I didn't know it was his brother involved either, so credit to him as well. So yeah, I'm excited about it. And so, like this little one I'm doing right here, I'm working on a little project to do a stepper encoder. And this is actually the shape of the copper. And the little sensor, it's an inductance sensor, is in this little circle. And so as this goes around, it knows how much copper's under the inductor to know its position.
Right.
And I actually would want to mill the outside of this to keep the copper. So this is an important SVG file for me that was done sort of algorithmically, but then to convert it into toolpaths was always a challenge because it's a complicated drawing. And I found the MakerCam just fell apart on it.
Oh, yeah. I'm surprised it didn't start on fire.
And when I brought it in here and it worked from the get-go, I was like, wow. So, and now the fact that he added this little ChiliPeppr button, super excited about. So he uploads it. Let's hope this still works because he's supposed to give a little. Oh, I see. So look at the Simulate G-Code tab, save your G-Code. I don't know, maybe it worked. But then over here, you're supposed to hit refresh. And it's supposed to be in this menu, and it's not. So I don't know what happened here. We'll just change the name. ChiliPeppr. There it is. Come over here, hit refresh, and it's in the list. Boom. Done. Ready to mill. So really cool. Now the way that that's working is ChiliPeppr is actually running a Google App Engine, which is so great for the maker community because it's just free. And it just he uploads it to the cloud storage call that anybody can do. There's a data put and a data get call.
Yeah.
So you just but it's one of those things that's not quite well documented yet. But you just say data put, and then your key is Edward, and your val is Ford, and I got to be logged in to store data. Oh, I am logged in, but I got to be in this domain. So, it's just cool stuff. So people could just inject stuff into ChiliPeppr, and then they could query it in their widget, and that's how we're doing this. So it's, if you go and fork JScut, you kind of see all that code and you just mimic it. So who knows if that'll go anywhere, but now we've got a nice connected workflow.
You know what? One of the coolest things I've seen in JSCut, and Todd has posted a couple of these to the forum, is you can do a gist, a git gist. Is that what it's called?
Yes. Yep. A
So
gist. Yep.
so basically, I could load up my SVG, I could generate all my toolpaths, and then you save this gist, and somebody can open it, and it's all like it loads the SVG, it loads all the toolpaths, and they can basically reproduce it. Uh, without having to go through, oh, I need to download the file, oh, I need to select these 20 different profiles and set up my operations. Boom, it's just open. They can click save. They've got G-code. So looking at what you just showed me, I think, man, you get this library of these gists and basically figure out a way to open the gist from ChiliPeppr, and boom.
Yeah. So you know what? I do need to go add that because Todd was making the really good compelling argument that if you're going to post something in a forum to ask for help to debug something, that's the link you put in there. Is the link to JSCut plus the gist ID, and now you're seeing exactly what that user is seeing. And I totally agree. It's a lot about collaboration, and you're right. That's not quite ready to go in ChiliPeppr yet. Although frankly, it's just a tiny little step because in ChiliPeppr you could just enter a URL. So if you wanted to share on a forum, hey, go check out my G code in ChiliPeppr, help me debug it. I really could just, if you added it right here, file equals, and it's a gist ID or it's an actual URL, boom, ready to go.
Yeah, Todd and I talked a little bit via email about I would love in JSCut to see a button that said like create gist, because it's like an 8-step process. It's not hard to do, but like you've got to sort of work through the system to make it. I would love a single button, boom, create gist. You get a URL back, and that's it. So.
Yep. I agree. Or, do you almost integrate gist? Because like this JSCut stuff I was showing you, these are just in the cloud storage of the ChiliPeppr server, so maybe that's just the way I do it in the ChiliPeppr world. I don't know. I'll think about that, but the key is collaboration. I think is where.
And I think between both JSCut and ChiliPeppr, from what I've seen and understand of both of them, collaboration is pretty straightforward. If you want to work on it, there's a way to do it. It's not overly complicated.
Yeah.
I think a lot of cool stuff's going to come out of this.
Well, so one of the things then that this was launched over the weekend, and this was so easy to do. This probably was like 30 minutes of work. Was this idea of macros, because I always hear people be like, I can't. Can I write macros somewhere? And I think Mach 3 lets you do some of that. But sending code like this little for loop of XYG code commands, doing that anywhere else, I don't even know where you could do this. Where you're sort of
when I saw your comment about the about writing these macros, the first guy that I thought of, and I'm embarrassed that I don't remember his name, but he's one of the first like 50 Shapeoko users. He made this really cool like PCB board. It was big and it had hundreds of little surface mount LEDs on it.
Oh, nice.
And he bought the Shapeoko like basically a pick and place. To just pick up these LEDs and drop them in the right position, but he did it with Perl. That was like the only thing that he had.
That's all he had.
He could sort of parse it out with. So when I saw the macro thing, I was like, dude, that LED board guy would have loved this, because it's exactly what he was doing.
I agree.
Just a loop until you're done.
Right. Why? Because you know what? He's not going to go find a piece of software like a CAM app that lets him produce that grid the way he wants. But he probably, if he thinks about it in code, he's like, it's a couple for loops, and I'll just set up my spacing, and I'll pump out the G code, and I'm done. But then what do you do from there?
That's exactly what he did. And then, if you make a bigger board or a smaller board, well, you just rewrite the script, I guess, your Perl script.
Yeah.
And, export your text file and then run it. But yeah,
so I'm gonna run this. I'm running this macro right now, so you can see where the tool head's at, and all it's doing, and you can see it moving. I know you get the little lights blinking down there. Mm-hmm. Watch the planner buffer, because that's a little scary. But all it's doing is it's saying go from X0 to X10, so from 0 millimeters to 10 millimeters, and then go in the Y direction from 0 to 10 each pass. So it's just going to go to 10 and then back down. Really stupid basic grid, but, you're good to go. From a little
Yeah.
tiny little line of code. And then just go tweak it. And, of course, it's spitting out where it's at. Um, I just still, I don't know anywhere else you can do this. So, but, even just something as simple as how do I send G code? That's it. Or one of my favorites is put a bounding box around the 3D viewer object. So I'm going to run that. There you go. You get a bounding box. And that's not even, there's no button inside this UI to do stuff like that. But if you want to kind of just go extend to get fancy, so who knows what people will do with it, but then the goal, and I don't have it built yet, is to just share that macro. So it's kind of like that whole gist discussion. Like, just let everybody else have access to it.
So it's interesting thinking about the macros. Like, I don't know how much you've used Mach 3, but Mach 3 has this feature that they call wizards. In the industrial world, we call it conversational programming. So it's all of these sort of built-in functions, like very common things that you do with a machine. Like, I want to make this bolt hole pattern, So you tell it just a couple basic pieces of information, and then it generates the G code. All of those wizards are built into Mach 3. But looking at your macro setup, it's basically the same thing. So if you could figure out a way to store those macros, like, hey, these are the most common macros. And the one that I thought of right away, John, was just facing a piece of material so it was, true to your tool.
Yeah.
Save all of these macros, give them a name that's recognizable, and it's like, okay, well, it's time to face off my MDF piece that I use to mount my PCBs on before I mill, so it's flat.
There you go. That's sweet. That's a perfect macro.
Yeah, absolutely. So you would just give it the basic information of, hey, this is, it's 100 by 150 millimeters. I'm using a 3.175 millimeter end mill.
Yep.
Go.
Exactly. You got it. And so maybe you do it as a macro that sort of directly sends the G code, or maybe you just have it generate G code. And it's like this one where you're just going to load the G code into the workspace, right? So there's just some G code, and it loads it, right? So I've got this fancy G code loaded, but I'm going to run this macro. Maybe I have code that's generating all my G code, like that leveler you're just talking about.
Yeah.
And then I run it, and it just generated it and stuck it into the standard G code viewer.
Right.
And then you play it from there, because then you're getting visualizer and everything.
And that's exactly how Mach does it. You go through this wizard, and then the button is post G code. So then, boom, it sends the G code back to the same place that if you opened a G code file from a text file. And then, for exactly the reasons you're saying, like, okay, you've got the visualizer, you can see the extents, X, Y, and Z, make sure you're homed, boom, go.
Right. Like, I just adjusted it to 6.5. And I think what's flexible here is you could do it either way. You could generate G code and do it where you're now able to kind of jump to what, each spot is in the G code. Because if you click in this G code, it's kind of jumping to each exact spot. All that fun stuff. You can even, I don't know if you noticed some of these options, but you could just, when you hit play, only send it to the 3D viewer, then the serial port. So you can actually kind of mimic it. Or again, there's just this simulator. So.
Right. Yeah, I was actually just going to ask if there was a way to just straight up preview without sending.
Yeah, there's multiple ways. In fact, I know it's confusing to some that there's play and pause buttons up here, but that's just a sample run. And then these down here are controlled from this little setting. And there's some stuff in here. Like, even on a tool change, it'll throw up a little dialog box and pause if you set it. I know that for some that matters. And this could, this thing could get lots of stuff added to it. Because, again, all that's just, you just go and you fork this thing.
So what sort of guarantee, I actually hadn't, I don't think I realized that the whole thing was like built on JS Fiddle.
Yeah.
What sort of guarantee do you have for that fiddle to stay around?
Fiddles stay around forever. That's
Okay.
been asked a lot out there. The JS Fiddle guys are pretty much like the GitHub model. They're here forever. And I actually would like for the JS Fiddle guys to see what I've done here, because I think they would realize that they have a better version of GitHub than GitHub has for JavaScript web apps. And they really do. GitHub is almost trying to be everything to everyone with respect to source control. And when it comes to a web project like this, I believe JS Fiddle's onto something stronger, because you can build stuff as a component, and then loading JS Fiddles into JS Fiddles. I've never seen that done before. They almost should do it, because you'll see there's this ChiliPeppr load all over the place, and that is doing some trickery where it goes back to the ChiliPeppr server to then retrieve this URL and slingshot it back to you through a proxy to sort of get around the fact that JS Fiddle doesn't have a way to load other fiddles. I wish they did.
Yeah.
Because it is so powerful once you start doing that. I mean, this is a really sophisticated app at this point, and each one of these is a standalone widget, but they all talk to each other through this pub/sub model. So the TinyG widget or the Gerbil widget receives the serial port commands, and it parses them and then sends axes update commands to the axes widget. But if the axes widget isn't loaded, nothing breaks. It just ignores the pub subs. So the pub subs are like this really loose coupling way to just keep adding more. Or when I added the auto level widget, or frankly even, let me go back to the macro, you can listen in on those pub subs so that you can manipulate them or mangle them or play with them. So this watch G-code response. This is only really doable with this pub sub model, but what I do in this macro is I send the z-axis from one position to the next, and then I trigger code when I achieve the position. So let me go ahead and run it. And I'm moving down to 3, really slow, and then see this little JavaScript alert?
Mm-hmm.
I triggered JavaScript when the TinyG or the Gerbil told me where I'm at. You can't do that in G code, because you can actually like pivot and like do if statements. But it's just listening. See this little unsubscribe and subscribe?
Mm-hmm.
It's just subscribing to the command being fired off by the serial port widget. And of course you wouldn't know what that command is, but you come over here, you go and look at pub/sub for this widget, and it's all documented. It tells you exactly when it receives a line from the controller, it publishes it, and you just listen to any of these. So these are like global little events. If you get a list of ports, or when the WebSocket connects or disconnects, this is how you send. So yeah, this gets a little nerdy, and you got to take a little bit of time to read all this stuff, but it's like self-documenting.
Mm-hmm. Yeah, pretty amazing.
And of course I got to mention that you get a text message when your job's done running.
That does not surprise me. I would have actually been really disappointed if that wasn't.
I had to add that. Just had to do it.
So should we talk about hardware right now?
Yeah, please, because Beagle Bone Black I'm excited about.
Yeah, talk to me about Beagle Bone Black.
So, Raspberry Pi's awesome. I've done a lot of stuff with Raspberry Pi. It is a little bit underpowered to some degree, and I think price point's always a sensitive thing. Beagle Bone Black's a little bit pricier at what, 50 or 55? Maybe 45?
Yeah, maybe 50, 45 or 50, I think, right now.
And, Raspberry Pi's still around 35, but the idea of that single board then controlling what you're doing, as opposed to a monolithic board that's got a processor on it like the TinyG, plus the stepper controllers, why can't you just use a Beagle Bone with some stepper controllers as a little add-on shield? Or what do they call them? Capes?
Capes, yeah.
And capes. Then it comes preloaded with, or you just throw on the serial port JSON server. And that thing's, and maybe it's got a little video camera on it to give you your little WebRTC feed, and now you got a good setup.
So have you run ChiliPeppr with Beagle Bone? yet?
I have not, but I know Riley Porter has, and he's the one that gave me the Beagle Bone compiled binaries. Although, frankly, I don't think I needed them because I think it's just the Linux ARM binaries.
Yeah, yeah.
But yeah, it works great. It works awesome.
So, BeagleBone has real-time support that Raspberry Pi does not, which I think made it an immediate candidate for Linux CNC, formerly known as EMC2.
Yes.
So there's what do they call them? It's basically an image, pre-built image of Linux CNC that's been ported over to the Beagle Bone Black.
Yeah.
And from what I've played around with, it's pretty legit. I'm gonna have a hard time showing this, but I've had this set up. This is from the back.
Are you share? Oh, you're sharing yours. Yeah. Let me see.
Yeah, I've had this set up.
Oh my God! Look at this beast.
This is totally proto board, right? Like just laser cut acrylic. There is a Beagle Bone Black, and then I've got just a regular G Shield. And then basically just jumpers from the G Shield to the Beagle Bone Black.
That's awesome.
So if there were a PCB, and I think somebody has probably already designed this, but if there were something to adapt the pinout of the Beagle Bone Black to the G Shield, you could literally just snap that thing on, run the image, the pre-built image, and you're off and running. On the front side of this, I bought this really cheap, it's like a 7-inch, HDMI screen from eBay. I think it was like maybe $60.
Nice.
And it's literally an all-in-one, full-on, all-in-one controller. So the bad part about it is, if you've ever used Linux CNC, the UI is pretty terrible. I think it's really scary to people who have never, it looks more industrial than what a Garble user would be used to.
Right.
So again, some pros and cons, but I'd be really interested to see ChiliPeppr running a Beagle Bone Black.
So I think that if for instance you were to do the Linux CNC, I think that interfacing into it wouldn't be that big of a next step. Because instead of binding into the WebSocket server maybe for the serial port, I don't know, does Linux CNC have open APIs? Does it run like a little web server so you can kind of control it? I imagine you can.
Yeah, there's actually, and it's part of the image, there is a web interface. So when I saw ChiliPeppr sort of understood what it did, I thought, man, it would be really great just to replace the existing web interface, because again, the UI is pretty terrible. It looks just like the non-web version, like it's just intimidating. So thinking, okay, just rip that out, replace it with ChiliPeppr, and you're running with the Linux CNC kernel. It's a match made in heaven.
So I just like I showed you the creating of that Gerbil widget and forking the workspace and that boot script. That's all you'd have to do the version for Linux CNC is like tweak that one widget, maybe drop the serial port widget. You're still going to benefit from all of the 3D viewer, the G-code sender, the macros, the JS cut integration. Like that's why ChiliPeppr is more of an operating system. It's open source. It's for anybody to go modify because the community needs it. And then if somebody's going to go make the 3D viewer better, or somebody's going to go, add a pick and place capability to it, then it sort of almost then doesn't matter what the controller is, whether it's a Gerbil or Linux CNC or TinyG.
Right. Yeah. It's super exciting.
Yeah, I think I'm excited about it too. So I want to see more of that device you just had. That thing's crazy. You got like a stepper motor on it. I'm assuming that's for debug.
Well, yeah. Instead of so this is the front. Oh man, I wish I would have grabbed the keyboard. But I've got this little Wi-Fi keyboard that I use to control it. The stepper motors are just X, Y, and Z. They're plugged into the G Shield. So I could basically run full jobs, I've got a little piece of tape on the stepper so I can see them spinning.
We all do that.
Yeah. So yeah, it's basically like carry it around, show it to people.
So
It's worked pretty well.
Could that maybe lead into your next project there, where you do get a little bit more into the electronics part of the machine itself?
Yeah, I think it would be really neat to have an all-in-one deal, right? Like prior to Garble, everybody used a full-on PC to run their machine. So that they used something with a parallel port, and they either ran Mach 3 on Windows or they ran Linux CNC. When Garble came out, it was like, what? The only thing you're using the computer for is to literally send a text file over serial, So it was like, this is completely overkill. So it sort of planted the seed of, man, it would be really great to have this sort of headless CNC. And that was probably 5 years ago that I started messing around with that. In reality, you don't want a headless CNC. Unlike 3D printing, where you can just sort of pop in a card and click print, with a mill, there's some interaction with the machine. So having some sort of visual interface is pretty important, which is why I've got that little 7-inch screen on there. You need to be able to pause the job. You need to be able to switch bits or do whatever you need to do. But you don't need a full computer to do it, like a full-on laptop or desktop. The Beagle Bone Black, I think, is amazing because it is a computer, but it's $45.
Yep. Although, the way I look at it is that you would use like a web interface that you could pull up on your laptop or your phone, for that matter, and pause the job. Change, control it, because you almost need like your Adobe Photoshop of mangling your G code and seeing it and visualizing it, and then it's just sort of controlling the remote hardware. So I feel like to then make like the Beagle Bone be the UI as well as sort of the controller, do we really even need that when we all have the most kick-ass laptop? Because we're all sort of our own geekiness, and that's going to be oozing with power and a full GPU and a nice screen and good internet connectivity. Just let the machine be a little bit more dumb and embedded. But even that dumb side, if it's pulling down 4 video feeds of the different axes and stuff, let it do some of that, but then get it up into a sophisticated environment like a browser instead of trying to make it do all of that.
Yeah, absolutely. I think people have been looking for this reason to use a tablet with their CNC, and thinking about integrating some sort of modern UI with the Linux CNC kernel. Seems like, man, that really is a match made in heaven. You've got this little tablet, pause it, start the job, change tools, whatever it is. It's got enough power in itself to give you all the sort of visualization you need.
Yeah.
Pretty promising.
Well, so we should probably wrap up here pretty soon. I know it's getting late for you. What do you want to sort of see in the next few years here in the CNC maker community?
I'd really like to see. I'm jealous of the 3D printers that their software and their hardware, for the most part, are completely aligned. One's not ahead of the other. We're still behind software-wise, both from a control standpoint, like Universal G-Code Sender is great, but it could be better, and some sort of the CAM, for the most part, open source wise, is lacking. So there's a lot of promising stuff coming up, man. I feel like Jscut is really like the beginning. We're going to see a lot of great stuff come out of that, and from what I've seen of ChiliPeppr, I think it's going to be pretty great.
Awesome. Well, thank you. I think I still think there's going to be factions of different people doing different stuff. Some people are milling wood. Some people are milling metal. I actually love the PCB fabrication side, and I'd love to see more there. I'd love to see more of a real pick and place where I could order a little baggie of components from Edward Ford's online store, and it's the whole program. It mills out the thing. It it pick and places the components. It's got image recognition, so that, like the 3D print world, which I'm a little jealous of too, could you print out an entire circuit board from start to finish, all the little steps? Because with the software today, I don't. Is it that unachievable? I mean, I know it's a little bit of a dream, but
yeah, it seems doable. Some obvious technical hurdles to get over, but it's not like it's not impossible.
Right. So I'm excited for what we're going to see too. Hopefully, we see some really cool stuff from your camp. So we'll keep talking.
Yeah, that sounds good. It was great chatting with you.
Great chatting with you as well. I'm glad we got to do this.
All right. Well, take care of yourself. I'm sure I'll talk to you soon.
All right. You too, Edward. Take it easy.
All right. Adios.